Thank you very much. Let me get this on the slideshow mode. Yeah, so good evening. I'm happy to present this work, which is done as a part of the first author's master's work. The second author is also a former master's student who kind of overlapped. I am Koshy Varghese. And a lot of this, I'm glad that Varun is here because this has kind of evolved out of what Varun started several years back at IIT Madras. So basically, what we have been doing is, I think I will start with where Varun was. So it was during COVID, we needed data for our progress monitoring engine. And he would, I think it was around the time when the iPhone released the LiDAR. And I think Varun would go, I think he was at his home and he would take all the construction projects around his house with the LiDAR, with the iPhone. And I would be at IIT Madras and said, look, this is not dense enough. Can you get us, why don't you take the LiDAR from IIT and go and get it? But then due to COVID and many other limitations, all we had was iPhone data. And I was expecting LiDAR data. And so I was wondering whether his model would be validated well or not. But we said then, I mean, why should we? I mean, and it looked like the iPhone was giving pretty good results. And he was kind of saying it was much faster. It was, rather than put a LiDAR in many places and get data all over, things seem to be better. So that got us thinking. And so we kind of said, look, we need a model to be able to compare whether I want an iPhone, I want a LiDAR, I want a photogrammetry solution. And I think we've seen a lot of publications in our conference here and around, which tend to use all of these data acquisition methods, but there does not seem to be a framework, or we did not come across a framework which we said, look, in this position, this is better, that this is better. So this is what motivated the work. So I would just go through this outline. We have basically, I've outlined what we're going to do. And so when we went into manual data acquisition, so we want now computer vision based data acquisition, but we have so many options. And if we look at the whole pipeline for computer vision based data acquisition, we have the basic data acquisition, we have the 3D reconstruction, the as-built model. If you have an as-planned model, then you have the progress visualization and quantification. So this is the way we have initially done the framework. And when we go into just the data acquisition part, we have all these options. So which option should I use and what is my purpose? So this is kind of the question which we raised to ourselves. And how would, if I were a project manager on a site, and so incidentally in India too, now we have a lot of airport projects coming up. And one of the contract conditions to the contractor or to the PM is that you will use some form of automated updating of the BIM platform. And everybody is now mobilizing LiDARs. And now, are you going to do it? Is it worth doing a LiDAR for the kind of progress monitoring they're doing? Or do you want an iPad, iPhone, mobile platform? So this was the question which we have. And most people are doing it not with a mobile platform, but with a static platform. And so one of the first things we had also defined was the levels of progress monitoring. So I think this becomes quite important. So you need to understand what the level of progress monitoring you want is from the exercise you're doing. A lot of times we find that people are okay with just visualization. So when we say L1, it is just to see what's being built, in a remote place or something. So this is the as-built condition of what is happening. When we say L2, it means a as planned versus as built comparison. When we say L3, it gets a little more. Now we are going to quantify. We have to get quantities out of what we are doing. It could be a percentage complete quantity. It could be a BOQ quantity. So as Mani presented, if you actually want to generate your earned value report, you want to generate billing to your client, you want to get invoicing, which is really very important to these companies because cash flow becomes important, then you actually need to be at this level. Now, if you are only going to be at this level, then it doesn't make sense to start processing or acquiring data, which is at the more detailed level. So if we look at the levels of detail. So do I just want a building at this level? Do I want to know whether the formwork has been installed? Do I want to know at reinforcement level? As we get finer in terms of what we need and what we want, we would have to keep the level we want also in mind. So there is two sides to this. So now we came into looking at, so the content of this paper mostly is a literature review. It's a review of what's been done. What are the factors that have been considered when people have compared devices? Because we thought that would be the start. We do have a model which was worked on later, but I think the ISARC paper deadline was over, but we didn't put the model in there. But it's still, I mean, the basis of the model is here. So we looked at, the various studies and to identify systematically how we would compare the technologies. So I think this becomes a fundamental requirement. I'm not going into the details, but Prisma methodology was used. Several papers were reviewed. Finally, articles on comparing the technologies in construction, we had about 18 articles. And basically we looked at, so most papers compared two devices, but there can be multiple devices in this whole process. Okay, but most papers compared two devices. And these where they had mobile scanners. So these are the number of articles which did the comparisons on mobile, terrestrial, range depth, photogrammetry, and videogrammetry options. Now just going in, so these are some of the factors. So these are almost, so we had factors which we classified as quantitative and qualitative. And what you see here are the number of papers which have referred to those factors. So we had accuracy as a factor, time of acquisition, system storage, resolution, cost. So these we are calling them as quantitative factors. And these are the qualitative factors, visual quality, influence of material. So these are all the factors that came out of the review, the literature review. Now, the question is, how do we put these factors in? What is the expectation from a project manager or a schedule engineer who wants to use this platform to be able to do progress monitoring? What is the expectation from them? And how do we factor all of these in? So for this, we actually need metrics to quantify. So I might say I want high accuracy. What does high accuracy mean? I would like it to quantify it. I might say I want a resolution. I want cost at a certain level. I would like to quantify it. So a lot of what the work we have done is to then look at, when you're going to quantify a resolution, what are the factors you're going to use? What are the metrics? So is it a 3D density, 2D density of points, completeness, point spacing? So these can be quantified. You can get a number out of it when you actually use the device onto a platform and you have a benchmark. You actually do take a photograph or take an image you want, and then you quantify the resolution to in your condition. Accuracy, you can quantify it. So these are the metrics which you're using for quantifying. I'm not getting into the details. Yeah. And then cost, all of this can be the quantitative factors, more surface coverage, system storage. So all of these are quantifiable. And what we are recommending as we go into the future is, when a new device comes out, these factors have to be quantified. Like you have a passport for it, for a construction progress monitoring, we should say that these devices are, have been benchmarked, and these are the kind of factors you get. For example, for the iPhone, I think if you went into asking for the accuracy of the LiDAR, my understanding is you cannot get any technical definition on it. But I think we have to do the experiments ourselves and be able to then find out and publish these results so that we can use it for the community. Now, once we have quantified this, so these are the are the metrics that we have to identify through. So these are the metrics identified by literature, the various metrics. Through experiments, we have to actually quantify. Now, if I want to apply it to a situation, I need a weightage. So the basic model says I would weigh a factor based on the weightage and then get an aggregated weighted score, which I would then add up to get my total weight. It's basically a weighted model. Now, in this weighted model, getting the factor weight can be a problem. We have tried to use AHP. AHP has its own problems. When you go into an expert and ask for pairwise comparison, it has its own problems. But then you have to put them in a situation. So the test case we did was one of our buildings in our campus, where the project manager wanted progress monitoring. They only wanted visual progress monitoring. And we have got I'm not presenting the results for that, but for that device, iPad or an iPhone LiDAR was more than enough because it was only visual progress monitoring. And okay, so this would be the AHP kind of approach. And so this is kind of what Aakar has been doing. Let me see where the other one is. Yeah, so again, I don't think the rest, you can't see it, but we're basically comparing the iPad with the terrestrial scanner. So we have a comparison done for this. It's kind of more at a research work, but coming down to what we have not touched is on the range of the device and uh, how it's impacted, and more work is required on the qualitative factors. But I leave you with this thought. I think we have emphasized it in several places. I think part of the construction industry, we need a standardized test bed. We need these devices are coming out. I think by the time we might be in a couple of months, the next iPhone comes, its specifications are different. We really don't know what the specs are, but we really need a test bed to be able to put this up, change the lighting conditions, change the distance, change the angles, change this, and find out what the different parameters are, and then be able to find which, be able to calibrate it in such a way we are able to then use it with confidence in the industry for the appropriate level of progress monitoring. Let me stop with that. Thank you.
Thank you so much for that presentation. We can move to the second one. According to the program, is Emre Ergin presenting?